So today we're going to be talking about strabismus and a special context, which is strabismus without diplopia. So as you know, diplopia is the symptom, it's what the patient says, and strabismus or ophthalmoplegia is the sign, it's what we see. And that strabismus can be esotropia, eye turned in, or exotropia, or hypertropia, eye turned up. And it really doesn't matter which direction the strabismus is going. The key feature of today's talk is that they don't see the double image. So when we have diplopia, it's because the two foveas are not aligned on the target. So if one eye is looking over here, then the fovea is not looking at the target anymore. It's looking over here instead of at the X, they are looking at the Y. And so when you have an X and a Y, you'll get double image. And that we call diplopia. So what are the reasons why someone would have a crossed eye, an exotropia, but they don't have the subjective complaint of diplopia? Well, one reason is one of the eyes can't see. So if you can't see the image, you will not appreciate diplopia. So this eye is 20/20 and this eye is hand motion. Even though their eyes crossed out, the patient can't see, so they don't have it. The other reason someone might not have diplopia is they're ignoring the image. So they can see the X, but the Y is so far away because the eye is so turned out that they can just ignore the second image. We can also suppress the second image. And that suppression can occur on a cortical basis. So even if you have normal acuity and you should see an X and a Y, you should have diplopia, you might cortically suppress the image. And so suppression is slightly different than ignoring the image because suppression means it never actually reaches conscious level of appreciation of that second image. And that type of suppression occurs if you have the strabismus before a certain critical age in childhood. And so strabismus is one cause of childhood amblyopia. So there's actually nothing wrong with the eye, but the cortical maturation process that connects the two foveas and the retinal input into the cortex has been suppressed at the cortical level because the strabismus is acting as an amblyogenic etiology, and that we call a lazy eye. So patients may have decreased vision in one eye because they have amblyopia, because the cortex has turned off the second double image, and so they don't see double because they have amblyopia. However, some patients have totally normal acuity in both eyes, 20/20 in both eyes, and are able to alternate their fixation, even though they have strabismus. So one eye is straight, the other one is looking over here, and then all of a sudden they're 20/20 in the left eye, but the other eye is looking over here. And that type of cortical suppression of the second image is a facultative cortical suppression. And what that means is we have a suppression scotoma. They don't see the second image, but only under binocular viewing conditions. Under monocular conditions, the facultative suppression scotoma turns off, and the brain is able to see 20/20. So patients who have had a facultative suppression scotoma can be detected with a number of different tools, the most famous of which is the Worth 4-dot test. So in the Worth 4-dot, we have a red and a green glasses over each eye, and we are presenting them with a flashlight with circles, and usually there are 2 red ones and 3 green ones and one that overlaps. And so in a patient who has a facultative suppression scotoma, they might not see the green lights or they might not see the red lights. In a patient who has diplopia, they'll see 2 sets of lights, all the green ones and all the red ones, they'll see 5 lights. And if someone's fusing, they'll only see 4 lights. The overlapping red and green, 2 reds, 2 greens. And that is one of the ways we use the Worth 4-dot to tell if we have suppression of one eye or the other. And sometimes the patient has strabismus and they really don't have any diplopia. And that's because even though the light is not hitting exactly on the fovea in each eye, the corresponding retinal elements are not corresponding. And that we call anomalous retinal correspondence. So normally every point on your retina corresponds with the exact same point in the other eye, and that is normal retinal correspondence. But if you have strabismus or your fovea has been pulled because of traction from a scar when you're a kid, your brain might be able to rewire it so that you have anomalous retinal correspondence. And if that anomalous retinal correspondence happens to be harmonious, you won't see double. And the important thing about that is, if the eye looks crossed, but the person doesn't have diplopia, and you do the Wirth forethought and they do not have diplopia, that could represent harmonious, anomalous retinal correspondence. And what that means is, for that person, that cross eye is their straight. And if you straighten that person out, now it looks straight, but the retinal is not corresponding, and you've turned someone who was asymptomatic with no diplopia into a diplopic person, even though you made them look better by straightening their eyes. And so recognizing the major causes of someone being ophthalmoplegic or strabismic without diplopia, you should be thinking about, can they see? If they can see, do they have a suppression scotoma? Or are they just ignoring the second image? And if they looked crossed, but they don't have diplopia and it's straight for them, that could be harmonious, anomalous retinal correspondence.